Okay, Lexi, here is number 24 from lesson 51. So we see here we have a trapezoid. Remember, a trapezoid has two parallel lines and two legs over on either side. So this is a trapezoid RSTU. So you can observe that with me. RSTU. That's our trapezoid, okay? We are told that VP, and I'm going to go ahead and mark all of this up, and you can do the same on your end. I'm going to use red maybe just to kind of make it stand out a little bit. VP, side VP, let's find that. VP is equal to VQ. Good, so I see a little isosceles triangle going on right there. RP is equal, we'll put two little tick marks there, to UQ, which is over here, and SQ, which is this big long line. I'm going to do that one in blue, maybe. So SQ is the longer line, so we'll put it like this. Nope, that doesn't work. You can't see it too good. SQ, which is the whole big long line, is equal to TP. Okay, but just make note of that. It's the entire line here. Okay, so there we go. So let's see what we have. Now, what we have to prove here is that trapezoid RSTU is isosceles. So remember what that means? That means that we are looking for the legs to be congruent. So that means we're trying to prove these two legs on the left and right side of our trapezoid to be congruent. So what I'm already noticing here, and I don't know if you've noticed the same thing, hopefully you can say, oh yes, I saw that already. Now I can't mark this just yet. I can't say that those are equal because we don't know yet. We need to prove that. But I do notice that I have, watch this. I want to kind of show you here what we're going to go after. Two triangles that overlap a little bit. If I can prove these two triangles congruent, the orange and the yellow triangle, that would mean that that RS and TU would also be congruent, because remember, congruent triangles or corresponding parts, remember all of that? The corresponding parts of congruent triangles are all congruent. So if I can prove, if I can prove those two sides as being congruent, then I can say it's an isosceles, okay? So that's where we're going to go. That's where we're headed in this. So let's look at statement number 1. Trapezoid RSTU. We are told all this information. RP is equal to UQ, and we already marked that up. So that is given. Now let's look at this next step. RP and PQ. I'm going to try to turn my iPad here because I think I'll be able to expand. There we go. I can expand a little bit better here. Okay, so RP plus PQ. Let's look at that. RP is right here. PQ is right here. Okay, so what they're saying is RP plus PQ is equal to UQ plus PQ. Okay, and that has to be true because think about it. This little segment and this little segment are the same size. So if I add PQ to either one of those, then that's going to be congruent. And we'll see what I mean by that in just a minute. Let's go ahead and put in here if I add those together. So this is the addition property. All right, so let's look at this. So RQ, which is this big long one here, RQ is equal to RP plus PQ. That's what we just said. Now look at what I marked in green up there. And UP is equal to UQ plus PQ. Okay, so if that's the case, then RQ, the big long one that I marked in orange right up here, has to be equal to UP, which is this one here, right? All of this has to be equal to this. And that's something we learned a long time ago, betweenness of points, which means basically if I take a little segment like PQ, the one that's in the middle up here, right here, and I add it to this one and this one, it's going to give me the same length. So any two sides that are congruent, if I add something of the same size to them or the same length to each one of those, it's going to turn out to be the same. They're going to still be congruent to each other. Okay, and that's something we learned a long time ago. Just haven't really talked about it in a while. All right, let me get some of this stuff off of here now. Okay, so let's see what else we have here. Oh, in number 4, all as we did here to say that RQ and UP are congruent is we did some substitution. Because right here, see how these are the same? And then I added to that same length, I added 2 sides that were congruent, which is going to make these 2 sides, the longer sides, congruent as well. Okay, it's a little hard doing this on video because I can't use my hands to point at things and so forth, so hopefully you're following along with me okay. All right, so let's take the next piece of given information, which is the VP equals VQ. So far what we have done is we have said that, and I probably need to go ahead and mark this. So I'm going to remove these little red tick marks up here and put them more like this. So that side is equal to this side, this whole thing, remember? This orange part is equal to this yellow part in our triangles. So if I pulled these off, just to show you, because I know it's hard to envision this. If I pulled these 2 out, what we just determined was that this whole side length is congruent to this whole side length. Okay, just so you kind of understand what we were saying here. Okay, now if VP is equal to VQ, let's go find that. We actually marked that, mine is marked in red. So if VP is equal to VQ, what does that create? That's an isosceles triangle there, that little one. And I'm going to highlight that in pink. Right here, this little one is isosceles. So if those 2 side lengths are congruent, then the base angles are also congruent, remember, because that's a rule with isosceles triangles. So now we've proven that VPQ, its angle VPQ is congruent to angle VQP. So let's go write that down. I marked those in red up there so you could see them. Angle, so the measure of angle VPQ is congruent to the measure of angle VQP. And that was the base angles theorem we used. That's what that's called when you have an isosceles triangle and you can see that the sides are congruent, then their base angles are also congruent. Okay, the next piece of given information was this SQ equals TP. So let's go look at that. SQ equals QP. And I want to kind of get rid of some of this stuff that's drawn on here if I can. Oh, nope. I'm getting rid of the wrong thing. Okay, let's see if I can put back some of this stuff because I don't want to lose sight of it. Put this other one in yellow real quickly. These are the 2 we're trying to prove congruent. Okay, so that last bit of information that was given, we said is SQ equals TP. SQ, let's find that. Okay, so that's where I marked in blue, right here. SQ is the whole line. This whole line is congruent to this whole line right here, okay? Given information. So what can I say based on that? So far, what do I have? I have, remember these red angles I put down here? Okay, so what I'm going to do, these 2 purple triangles that I did here, I'm going to mark some things. We said those 2 angles are congruent. That's just taking the orange triangle down and the yellow triangle. This is the orange one, just so you can follow a little bit better. And this is the yellow one. Okay, we said that those 2 angles are congruent. We also said that these 2 sides are congruent. And we also said that, and this is in purple, those two bottom parts are congruent. So what do I have here? I have proven those two triangles congruent because I have side, angle, side. So based on side, angle, side, these two triangles are congruent. SQR and TPU. Those are the ones I pulled off and drew up top. All right, well, based on that, then SR and TU, let's put these little things right here so you can see it, and TU are also congruent. You need 4 little marks. Okay, we just proved those two sides congruent, which is what we needed to say that this was an isosceles trapezoid. So SR and TU became congruent because corresponding parts of congruent triangles are congruent. Remember, once we have two triangles congruent based on our side angle side in this case, then we say, well, then all the parts are congruent. Okay, so trapezoid RSTU is isosceles, and if you were to pull out your packet and look at definition 44, it says an isosceles trapezoid is a trapezoid, and I'm going to abbreviate that, that has both legs congruent. Okay, and that completes the proof for number 24 in lesson 51. Okay, 2 more coming up.